Before I start, I'd like to acknowledge I am from Wajjuk Noongar Boodja, Kaya, otherwise known as Perth, Western Australia, and I'd like to recognise that we are meeting today on the lands of the Ramaytush Ohlone and Muwekma Ohlone people to recognise their continuing connection to their lands, waters and culture, and pay my respects to their elders past, present and emerging. A little bit about me. I am a principal engineer in the open source group at Anaconda. They pay for me to attend conferences like this one, to talk to people like you, so I'd like to thank them for that support. I'd also like to, they also support the Python open source ecosystem more broadly by providing direct financial support to organisations like NumFocus and by employing developers to work full-time on open source projects like Jupyter and Number, and the open source project that I founded, BeeWare. For those who haven't come across it before, BeeWare is not a single product or library or tool. It is a collection of open source tools and libraries for creating native user interfaces in Python, for desktop, but also for iOS, for Android, for single-page web apps, and for console. Each tool in the BeeWare Suite solves one specific part of the overall problem of writing a GUI app in Python and distributing that app to other people on various platforms. Anaconda supports BeeWare to ensure that Python remains a viable programming language for the platforms that people are increasingly using as part of their day-to-day computing life, phones, tablets and so on. However, it is important to note that BeeWare is not an Anaconda product or anything like that. It is a fully open source project with independent governance and funding. I just happen to be paid by Anaconda to work on it full-time. And so today we're going to look at the BeeWare suite of tools and how you can use those tools to write and deploy a GUI app for desktop, for iOS and Android, all from a single Python code base, and how to access some of the capabilities of those hardware platforms. This is going to involve two major pieces of the BeeWare suite. The first is Toga. Toga is BeeWare's cross-platform GUI toolkit. It lets you use a single code base to write a GUI application that can target multiple platforms. And on each of those platforms, you get a native user interface. So on macOS, it looks like a macOS app. On iOS, it looks like an iOS app, and so on. This isn't just cosmetic appearance either. The apps actually are native. Toga abstracts the native system widgets and capabilities, providing a common Pythonic API to build your apps. This also means that you inherit all of the native capabilities of those platforms. So, for example, affordances like screen readers and adaptive font sizes just work out of the box. The second piece of BeeWare we're going to use is Briefcase. Briefcase is a tool for packaging Python applications. It takes your Python code, wraps it up as a standalone unit that you can give to an end user with no Python experience so that they can install and run the app on their phone, on their device of choice without ever knowing that they're running Python code. In our case, we're going to use Briefcase to prepare a desktop, iOS and Android app that could be submitted to those platforms' respective app stores. While it obviously pairs well with Toga, Briefcase is not BeeWare or Toga specific. You can use Briefcase to deploy a PyGame app if you wanted to. Briefcase can't magically make PyGame work on Android, but to the extent that a GUI library already supports a platform, Toga can generally support deploying to that platform. All right, so let's dive in. Let's write an app and then deploy it across multiple platforms. We'll start with something relatively simple, but we'll add more features as we go along. So where do we start? Well, Briefcase has a wizard you can use to bootstrap a new app. So we create a new virtual environment, install Briefcase, pip install Briefcase. With Briefcase installed, we can then run a wizard to start a new project. Run Briefcase new, you'll get presented with a list of questions with explanatory text. You get asked for details like the project name, your name, email, license details, your preferred GUI framework. We're going to create an app called PyBay Demo. We're going to use Toga for this example, but there are also templates for other GUI frameworks like PySide and Pursuit by Bear. There are also third-party toolkits like Pygame CE that actually provide a Briefcase plugin as part of their code base. Or you can select an empty project with no GUI toolkit at all. When you complete the wizard, Briefcase will generate an app for you and give you instructions on how to run the project. So let's follow those instructions. CD PyBay Demo and then Briefcase Dev. Briefcase includes a developer mode, which lets you rapidly iterate on your app and its configuration. So when you run Briefcase Dev, Briefcase looks at the project configuration that's been generated and works out how to run your project in your local virtual environment. The first time you do this, it'll install some dependencies based upon what your template generated, and then it will start your app. For what it's worth, Briefcase Dev is really not much more than a convenient shorthand for a pip install followed by Python -m PyBay Demo with a couple of debug flags and path settings set up for you. And if all you've got is the content that was generated by the wizard, at this point what you'll get is a working app. It will be an empty window, but it will be a working app. So let's take a closer look at what was generated for us by the wizard. If you looked in the PyBay demo folder that had been generated, you'll find all the code for your app, application icons in a variety of formats, and some project metadata. You'll get the same files regardless of which GUI framework you pick. The only difference will be the contents of app.py, donedomain.py, and some of the values in pyproject.toml and the README in the license file. So let's have a look at what was generated. PyProject.toml is your configuration file for the project. The contents of this file will match the answers that you gave in the wizard. All of the briefcase-specific options are defined in tool.briefcase sections and subsections. The top-level project and author identification is in tool.briefcase. Individual apps are then defined in their own sections, so this configuration defines a PyBay demo app, tool.briefcase.app.pybaydemo. At runtime, the configuration for the PyBay demo app is composed from the project settings overridden by the app settings. So even though there isn't an author name defined here in the app config, it'll inherit one from the project level definition on the previous slide. If you wanted to have a different author name for this version of the app, you could do so, just include the author name definition in the apps configuration block. Now, I said that app settings override project settings. There are 4 exceptions to this behaviour: sources, requires, test sources, and test requires. Sources defines the list of directories of source code that you want to include in your app. Here we're saying the source PyBay demo directory, any code or resources in that folder will get copied into your app. It's a list, so if you specify multiple sources, they will all get copied. The only requirement is that one of your source directories needs to match the name of your app, so PyBay demo in our case. Requires defines the Python requirements for your app, again, as a list using the same format you'd use as arguments to pip install. So a bare package name, a package with a version specifier, a Git repository, a path to a local folder that contains an installable package, a wheel, they're all options here. Test sources and test requires are the same as sources and requires, but they define code and requirements that will be installed when you're running in test mode. These 4 settings are cumulative settings. So if you specify a sources definition at the project level, any app level sources will be appended to the list defined at the project level. Why does this matter? Well, you can also specify options that are platform specific by adding a configuration section for that platform. The generated pyproject.toml will include a section for all of the supported platforms, so macOS, Linux, Windows, iOS, Android, and web. So here, we've got the specification for iOS and Android. Those options will only apply to builds of apps on those platforms. Sources requires, test sources, and test requires are cumulative, so any deployment on iOS will install all of the app level requirements from the previous slide, but it will also install Toga iOS and standard NSLog. A deployment on Android will have the same app level requirements, but won't have Toga iOS or standard NSLog, it'll have Toga Android instead. All other settings will override app level or project level values, so you could have an iOS app specific author name, for example. That's the project configuration. What about the app itself? Well, the logic for the app is all contained in app.py. At the moment, it's a bare stub. It declares a class called PyConDemo, which is a subclass of Toga's app, and that class has a startup method. That method creates a box, which is Toga's representation of a generic container of content. It creates a main window, sets the content of the main window to be our empty box. It then shows that main window. The main method for the app just creates an instance of that class. That is all the code we need to generate the empty app window that we saw before. So let's now replace that startup method with some code that actually does something. So in our startup method, we're going to define a static text label with a text your name. Toga lets you set the style of each widget using a subset of CSS called pack. So we tell Toga that we want this widget to have some padding, and the format is the same as it would be for a CSS padding definition. Then we'll define a text input so we can get some information from the user. Again, we'll give it a little bit of style. We'll mark the text input as flexible. Toga's layout is based upon CSS3 Flexbox, so marking the text input widget as flexible means it will expand out to absorb any available space. You'll also note we've attached the text input widget as an attribute of self, so as an attribute of the app. That's so we can access the widget later. We don't need to do that for the label because it's just static text, but we could have if we wanted to, and there are other ways to retrieve a widget at runtime if you need to. We then create a box, again, the basic container widget in Toga. We tell it that it's going to have 2 children, the label and the text input, and indicate that it's going to be a row box, so all of the children will be stacked horizontally with some padding. Next, we define a button with the label say hello and some padding, and declare that when the button is pressed, we want to invoke the say hello handler on the app. That is all the widgets we need for now, so we can define our app's main box. Again, this time we're saying the main box is a column box, so all of its children are stacked vertically. Instead of declaring the children at time of construction, we're going to add them one by one. Functionally, that's identical to what we did on the previous slide, declaring it in the constructor. It's just a different syntax that you can use dynamically. And so here we have a main box that is vertical, the first child of which is a horizontal box, which contains a label and a text input, and underneath that there will be a button. At this point, we can pick up where the old code left off, create a main window, set the content of the main window to be our main box, and show the main window. One piece of housekeeping to attend to, we said that when the button was pressed, we want to invoke a say hello handler on the app, so we'd better declare that handler. When we say that say hello is invoked, the first argument is the widget that generated the event, so in our case the button. There's only one button, so having that widget as an argument doesn't actually help us in this case, but if you had multiple widgets attached to the same handler, that might be useful information to have. What happens when the button is pressed? Well, we'll show a dialog to the user, an info dialog in this case, and the title of the info dialog will take the value that is currently in the name input and put that into the title of the dialog. Now, you may have noticed this is an asynchronous handler. Toggler will let you use any function or coroutine as an event handler, and Toga fully integrates Python's async.io event loop with the native platform event loops used by the GUI frameworks. Why would you want to use an async handler? Well, no matter the GUI framework, no matter the platform, a GUI app basically boils down to a loop. And that loop is essentially, while not quit, process events, redraw. Now, this is pseudocode, not a literal API on any platform, but honestly, it's not that far away from reality on most platforms. Every time you click a button, type a character, drag a corner of a window to resize it, that's an event. And the app code will respond to each of those events in turn, causing changes in the state of the app. Those changes in state are then reflected in the appearance of the app the next time it is redrawn. The critical detail is that when the app is redrawing, it's not processing events. And when it's processing events, it's not redrawing. If you've ever seen an app beach ball or have a little spinner icon or hourglass, that's what's happening. Your app is trying to process an event and it's taking too long, so it hasn't redrawn in a while, for some measure of a while. And so the operating system is telling you there is a problem by showing a beach ball. So, going back to our event handler, we want to show the user a dialog, but we might want to wait until the dialog has been acknowledged before we proceed with some other business logic. If the handler was a synchronous method, while you were waiting for the user to respond to the dialog, the event handler hasn't finished yet, and the app wouldn't be processing other events or redrawing. Depending on the platform, that might even include drawing the dialog itself. By using a coroutine and awaiting the result, we can say, okay, we're able to pass control back to the event loop. You can go ahead and redraw and process other events. And then as soon as the user actually presses the button, resume this event handler where we left off. All right, so that's all the code we need for a simple GUI app that will show a dialog when the user presses a button. So let's run it. We rerun briefcase dev, we start the app again, and this time you'll see an app with a label and a text box in a row, underneath that a button. The text box is flexible, so it expands to fill the available width. The buttons are flexible by default, so it does as well. Type in a name, press the button, and you get a dialog with whatever text was in the text input at the time you pressed the button. All right, so we've got our app running in development mode on our laptop. Let's run it as a full app. First step, we need to create our app. We do that with briefcase create. This will do a bunch of things. First, it will look at the platform you're currently on, get an application template for that platform. So I'm running on macOS, it will use a macOS app template. Second, it will obtain a support package. A support package is a version of Python that can be embedded into your app. Whatever your platform, Briefcase will download a support package, unpack it into the application template that was just created. Then Briefcase downloads and installs a stub binary. It's a literal executable that can be used to start your app. This is essentially a copy of python.exe that has been hard-coded to just start your application. You need this so that the app appears in your operating system's task manager as PyBay demo, not python.exe. Then Briefcase installs your application code, anything declared in your sources section of your project. It then downloads and installs your app's requirements, but it doesn't install them into your local virtual environment. It's installing them into the application template. You are building an app for distribution, so you can't rely on anything in your local virtual environment because your end user won't have your local virtual environment. Then Briefcase installs any application resources like icons, purges content that isn't needed, and it's done. You've now got a complete application template. Next step, build the app. Briefcase build. Whatever happens at this step varies from platform to platform. On macOS, it needs to sign the binary. On Windows, it needs to write some app metadata. On Linux, it actually needs to compile the stub app. And at that point, there will be a subfolder of your build folder that will contain an application along with any other files created as part of the build process. In this case, it's a macOS app. If you were to click on that little B icon, the app would start. Or you can keep it all console-based and just use Briefcase, run your app with Briefcase Run. It's effectively just the command line equivalent of double-click the app that was generated. And what you should see is a running app. It will be almost identical to what you saw with Briefcase Dev, with a couple of differences. The app will present to the operating system with your app's formal name, so PyBay demo in our case, rather than Python. It will have an application icon in your toolbar. Depending on your platform, there may be some other subtle differences. Having validated that our application works, we can now package it for distribution. Run Briefcase package, and Briefcase will do any final packaging needed to produce a single artifact that you can give to someone else. Again, what happens here depends on your platform. On Windows, it will create a full MSI installer. On Linux, it creates an RPM or deb package. On macOS, it'll create a DMG, signing and notarizing as it goes. Some caveats about packaging. At present, we only do automated signing on macOS and Windows. On macOS, we do full signing and notarization of the app bundle. On Windows, we sign the EXE and the MSI. We've got documentation on how to manage signing for mobile platforms, but the process isn't currently automated. Signing Linux packages is currently an unknown. Patches welcome. The framework is all in place. All we need is the specifics of how you actually specify and apply signatures to the app bundles. If you are on Linux and you want to package for another distribution, say to produce a Debian file while you're running a Fedora on your machine, you can, using Docker. Briefcase will manage the entire process of using Docker. You just need to make sure that the Docker daemon is installed and running. If it is, you pass in #target to any Briefcase command with a name of a Docker base image. Briefcase will package an app for that platform, so spit out an RPM for that platform. And it will also let you test the app by running the app inside the Docker container, exporting the X display so you can see the app. If you're on macOS, you can also build packages for Linux using Docker, but only for your current architecture. Briefcase package Linux with a #target, it will do the same Docker trick, but if you've got an Apple Silicon MacBook, you're only going to be able to produce ARM64 Linux RPMs, which is probably not what you actually want in practice. Unfortunately, Docker handling doesn't currently work on Windows natively. Apparently, it does work under WSL, though. You also can't build a macOS package on Windows or a Windows package on Linux because the tooling to build native Apple apps, native Windows apps are platform specific. CI platforms are your friend for this sort of thing. Some other features that are worthy of note. Although I've used the wizard to bootstrap this project, you don't have to use the wizard. You can manually write pyproject.toml briefcase configurations from scratch. Or if you've got an existing project with a pyproject.toml, briefcase convert can be used to add a briefcase configuration to that existing project. So far, we've been using briefcase command for all of the things we've been invoking. In every instance, that's actually a shorthand for briefcase command platform format. Briefcase will identify your platform and pick a default format for that platform. Most platforms have alternate formats. So you can, for example, produce a full Xcode project rather than just a simple macOS app, or a Visual Studio project rather than just a simple Windows app, or an app image or a Flatpak on Linux. Briefcase create Linux Flatpak will create a Briefcase Linux Flatpak. Briefcase will also imply earlier steps if they're needed. If you have a fresh project straight out of Briefcase new and you invoke Briefcase run, Briefcase will detect that it hasn't generated the template yet, so it'll create it, and then it will build it, and then it will run it. Briefcase run also allows for a -u option that will update the app before execution, so your development cycle could be just invoking Briefcase run -u over and over again. It's a little bit slow, which is why the development mode exists. Briefcase open will open your project. If it's a simple project like a macOS app, it will just open up your file manager on the build folder for your project. But if it's an IDE-based project, it'll open the IDE on that project. If it's a Docker build, it will open a shell session in the Docker container that was used to build the app, which can be helpful for debug purposes. All right, so that's desktop deployment. What about deploying to mobile platforms? Well, the steps are exactly the same. Just add iOS and Android to all of the commands, and you're done. Briefcase create iOS. Briefcase build iOS. Same for Android. iOS builds currently only work on macOS, or will only ever work on macOS because of the underlying tooling requirements, but Android builds will work on macOS, Linux, or Windows. When you run Briefcase run iOS, Briefcase will ask, where do you want to run the code? It will look for simulators that are installed on your system, provide a list to choose from. If you want to shortcut that question, you can specify -d and give a device ID or a device description, like iPhone 14. On Android, it'll walk you through the process of creating a new emulator image if you need one. And these commands will also manage the process of downloading the tools, so like downloading the Android SDK for you. But once you've picked a device, the app will start, and you'll see a mobile app that has the same layout as the desktop version, but running on a device emulator. Type in some text, press the button, you'll get a dialog. Briefcase can currently only target iOS simulators directly. Briefcase will manage the process of starting the simulator, launching an app in the simulator, tailing the log so you can see the app run. You can deploy to physical devices, but you need to use Briefcase Open to open the Xcode project, sign up for an Apple developer account, set your developer credentials, and then deploy to the device from inside Xcode. On Android, you can target emulators or physically attached devices. You do need to do a bit of a weird dance with the physical device to put it into developer mode, but Briefcase will walk you through the steps of getting that done. You can also use Briefcase to deploy your GUI to the web. As with mobile platforms, we've just added web to the end of each of the commands we've run so far. So Briefcase create web, Briefcase run web, build web, Briefcase run web. When that succeeds, it will start a local web server, open a browser, and you'll see your app rendered as a single page web app. Type a name, click a button, and you'll get a dialog. Now, this is a static single-page website. All of the app logic is running in your browser. It's not server-side. It's using PyScript to embed a full Python interpreter in your browser, and your app's code is running in the browser. When you press the button, the logic of your app's handler is running in the browser client-side. It's also possible to run this demo in the console as well. This is a Toga backend implemented using Textual. It's a little messy to set up at present, but it is possible. You can get it to run. Toga's web and console backends are the backends that need the most work at present. They're enough to run this demo, but they need a lot more work to be at parity with the desktop and mobile platforms. So if you're looking for an open source project to contribute to, just saying. All right, so we've got a cross-platform GUI app, but you're only going to go so far with text inputs and buttons. Let's add some more features to our app. What are we going to add? Well, Python's a popular tool for data science and visualization, so let's add a chart to our app. And since we want to add additional features, not replace the features we already have, we're going to need some way of navigating the content of our app. So let's add a tab widget as well, so we can switch between pages of content. Previously, we created our main box and set that as the content of our app's main window. Let's modify that a little bit. Let's create an option container widget. That's a tab widget and contains 2 pages of content, one labeled dialog and one labeled chart. And we'll set the main window's content to be that option container rather than the main box. We'll use the existing main box as the content of the dialog tab. And the second tab will use a chart box, so which we're going to need to define that now. Now, we don't want to get too bogged down on specific data visualization problem here, so we'll just visualize a histogram of random distribution of data with some controls for the mean and standard deviation. So we want a histogram. How do we draw that? Well, we're going to use Toga Chart, which is a matplotlib rendering backend that can render natively to Toga. We create an instance of the chart widget. We assign it to the app so we can reference it later. The chart needs to be flexible because we want to expand to the available space. And we set an onDraw handler. Whenever the chart needs to draw itself, it'll invoke a method on the app called drawChart. We'll define that method in a bit. We also want some sliders to control our random data. The setup here is very similar to what we had in with the text input. A label, a slider, the values of the slider starts at 100, can go from 0 to 200, and every time it changes, we're going to recreate the data by calling self.recreateData. Similarly for the slider, same setup there. We have a slider, we have a box. It's got a box that contains a label and the self.sigma. We've got some padding around it as well, and every time that slider changes, it's going to call the same recreateData handler. We also want to be able to manually regenerate data, so we'll create a button that, when pressed, calls the same recreateData event handler we used for the 2 sliders. After all, it doesn't really matter if we change the mean standard deviation or recreate the data, we just want to redraw the chart. Now we can put the pieces together. Before we draw the chart for the first time, we're going to need to get some initial values for the chart being drawn, so we'll wrap that up in a setData method. Come back to that one in a minute. And then we put all that content into our chart box. So our box has the chart, a box that contains a label and a mu slider, a box that contains a label and a sigma slider, and then a regenerate button, all stacked into one big column. So we've got our chart box now. Now we can fill in some of the gaps that I referred to along the way. We need a setData method to define a data series, just call NumPy to go and generate a random distribution using the current value of mu and sigma to adjust the values of the random distribution. And we have a recreateData handler that will reevaluate the data, get a new set of data, and then tell the chart to redraw itself. Now, just as with the button press handler, the first argument of is the widget that generated the event. Again, we don't care which widget generated the event, but if we did care, the detail is there to use if we want. Lastly, we need to actually draw the chart. This is also an event handler, so whenever the redraw is triggered, either because the window is resized or because a redraw has been directly requested by the user, this is the handler that gets invoked. It's an event handler, so the first argument is the widget that generated the event, the chart, but it also gets a figure argument, which is a literal matplotlib figure object. We don't want to draw the chart unless it's actually visible, so we shortcut the handler if the current tab isn't the chart tab. I'm using the label of the tab as the identifier here, but you could use a numerical index of the tab or the option item instance if you'd kept a handle to it. But if we know the chart is visible, we can draw that in that figure using any matplotlib API you want. This here is very much a matplotlib happens here slide. Don't worry too much about the details. Consult a matplotlib talk if you want to know how to do that. And that's it. We've now got a demo app that draws a chart. So let's run it. So before we deploy to our phone, let's just check it works in developer mode on our laptop again. We run briefcase dev and it crashes because it can't find NumPy. Well, okay. We're using NumPy in our project, but we haven't actually installed NumPy. So we need to modify our project to declare our dependencies. Go back to our pyproject.toml. The app section declares our requirements. We need both NumPy and Toga chart. Toga chart then in turn specifies a requirement on matplotlib, so that will be installed as well. I'm using a bare package name here, but again, I could have used a version specifier, a git URL, a wheel file, local file system reference. So save those changes, and we now run briefcase dev -r. The -r is needed because our requirements have changed, and this will, so we need to say, okay, go and actually reinstall all of our requirements. That'll install NumPy, Toga chart, and all of the downstream requirements of those packages, and then we'll see an app that has 2 tabs, and if we select the second tab labeled chart, you'll see a chart with 2 sliders and a button. We press the button, we get a fresh sample of 1,000 data points, we move the sliders, and the chart will update itself, modifying the mean and standard deviation. Okay, so we've got our app running in development mode on our laptop. Let's get it onto our phone. We could go through the whole process of recreating the app from scratch, but since we've got the app and we've generated it before, we can update the version we've already got. We could do that with briefcase update iOS, then briefcase build iOS, then briefcase run iOS. We need to pass in -r to the update call to tell briefcase that we want to update the dependencies to the app as well. Again, if we didn't do that, our app wouldn't have a NumPy or matplotlib because it's a standalone app. It has a standalone copy of all the dependencies. You've got to tell, hey, I need you to get the dependencies over onto this bundled app. Doubly important because you need the iOS versions of those dependencies, NumPy being having a binary wheel. Or you can actually shortcut that process and call briefcase run iOS -u -r. The -u says, okay, update the app before you run it, and by updating it then also does a build, and the -r tells it to update the requirements as well. Same commands apply to Android, just drop briefcase run Android -u -r. And so, when the app runs, you'll get an app with tabs and a chart. You'll also see the tabs are at the bottom, not the top, reflecting local platform variations. Mobile platforms put the tabs at the bottom of the container and at the top, so they're easy to hit with your thumb. So, in our demo app so far, we've used NumPy and matplotlib. What about other third-party packages? Well, it depends. If the package you want to use and its dependencies are all pure Python, just use it. Makes no difference. Put it in your requires list, briefcase update -r, and you're done. The only place it might have complications is if the package you're using has logic in it that says if sys.platform equals Win32 or whatever. If that logic exists, you might need to submit a patch upstream to get it to actually honour iOS and Android as valid outputs. Anything with binary modules, that's a little bit more complicated. On desktop, binary wheels just work. They're pip installed, distributed, no problem. On mobile, binary wheels just work as well, but most projects don't publish binary wheels for iOS and Android yet, if only because they can't be uploaded to PyBay at the moment. In fact, BeeWare is the only group that is currently building binary wheels for iOS and Android. We currently maintain independent pip-compatible repositories where they're stored, and Briefcase uses those repositories by default. If the package you want is on the list that Briefcase provides, you're fine. If it isn't, building can be complicated depending upon the package. We have built a bunch of common packages, NumPy, Pandas, Pillows, some older versions of cryptography. We are a small team though, and compiling the universe takes time. We have documented the process of adding a build recipe, but some packages are harder than others. Unfortunately, SciPy and OpenCV are the two commonly requested packages that aren't available on iOS at present because they need a Fortran compiler, and there isn't a Fortran compiler for iOS. We're working on that. This is something we're hoping will change very soon. As of Python 3.13, iOS and Android are officially supported Tier 3 platforms, and there is now an official wheel tag for iOS and Android, so we are now in a position to ask PyPI to actually accept iOS and Android packages. We have submitted the PRs upstream to CrossEnv to support cross-compilation of iOS wheels. We have submitted PRs to pip to support the official iOS tags. Android PRs for those should be coming very shortly. We still need to work on modifying CI build wheel and generally documenting how you add iOS and Android to your CI build matrices. That should be coming hopefully by the end of this year. We'll have the rest of the tooling in place so that our project could just add iOS and Android to their CI matrix and spit out iOS and Android wheels for their project as just part of a normal release process. We're hoping by the end of this year to see at least a couple of packages with official PyPI support. All right, so we have been building an app, deploying it to mobile. We haven't really done anything interesting with the fact that we're using a mobile phone though, so let's do something interesting with hardware. Let's go back to our option container and add a third tab, this time for a map box. What's in the map box? Two things, a map set as flexible, so it will expand to fill the available space, and a button that we can press to update our location. So it will also be an event handler when the button is pressed. Put both of those into a map box, and that's our layout done. We can now define the event handler for when the button is pressed. So whenever the button is pressed, let's go and poll the GPS on our phone, get the current location, and zoom the map to that location. Location services are strictly governed by platform permissions, so we can't just get the location. We need to make sure we actually have permission to get the location first. So we request permissions from the app's location service. The location service is a hardware feature that Toga has wrapped as a cross-platform API. There is also a camera service. We'd like to add others for things like accelerometers or any other sensors that exist on your phone. Asking for permissions will check if the user has previously granted permissions. If they have, this will be a no-op. If they haven't, a dialog requesting that permission will be displayed, and it will wait until the user's acknowledged or rejected permission. If the user has previously rejected permission, the request will fail and raise an exception. If it succeeds, we can then ask the location service for a once-off location ping that will return a location which we can use to set the center of the map, changing the zoom level while we're at it. We could also turn on continuous location tracking, and you just get a little callback every half a second, every second, you're just telling you where the update or where the updated location is. Or you could drop a map pin. The Toga's got APIs for all those sort of services. There is another exception that could be raised here, which I haven't included in the code, which is not implemented. Toga currently has a map view that works on all desktop and mobile platforms, but it only implements location services on macOS, iOS, and Android, so you can't get a GPS read on Linux and Windows at present. We'd love to fill that gap, so if you know how to do that with GTK and Windows, let us know. We'd love to have that patched. There are two other changes that we need to make, this time to the project configuration. We can't just ask for permissions, we need to declare that we might ask for permissions. Briefcase has a cross-platform representation for common permissions related to location services, camera access, microphone access, a couple of others, but there are also mechanisms for adding platform-specific permissions and platform-specific variations of permissions if you need to. In this case, we are asking for permission to know both the coarse and fine-grained location of the device. Not all platforms will differentiate between those two granularities, but Briefcase will let you specify both and then will do its best to interpret as best it can for local conditions. The values provided for those permissions are the text that may be displayed to the user to explain why location access is required. The text that I've used here is not a good example, so don't use that. On macOS and iOS, the text will be part of the app approval process, and your app may be rejected if it is not sufficiently illuminating in the eyes of your app reviewer. One last change, on macOS and iOS, map view is available natively with no changes, but on Android we need to add a third-party Android package for OpenStreetMap. This is added as a Gradle dependency. The Android build process will manage downloading the package in the same way that pip would download a PyPI package. So we need to add the OS Android line to our Android configuration. There is actually a similar set of configuration options for Linux to make sure system packages are available if you need a WebKit installed or something. Now, because we've changed permissions and we've added a binary dependency on Android, we actually need to regenerate the entire app. This is a side effect of how Briefcase works, the files that need to be modified to add permissions and dependencies. These properties are defined in core project metadata that is populated when the app is first created. By adding permissions and Gradle dependencies, we need to update those core files. And at present, Briefcase can't update existing core project metadata in situ. That's something we'd like to fix. We've got some ideas how it can be done, but at least for the moment, you need to Briefcase create from scratch. While recreating the app is a little confusing and maybe a little inconvenient, it shouldn't actually impact anything in practice. You should be considering the build folder of your project to be an ephemeral artifact. It could be and will be deleted at any time, replaced with an updated version. You shouldn't be manually modifying any files in your build folder. Your version control system shouldn't be storing into the artifacts of your build folder, and the CI process you use to release your app should be starting with a fresh build every time. When you do run create, when there's an existing build, you'll be prompted to confirm whether you want to delete the old project so you're protected against mistakes or inadvertent deletion. And so when the app runs one more time, we get an app with a third tab along the bottom and a map. Press the update location button, you'll get asked for permissions. If you approve permissions, the map will zoom to that updated location. Now, we're on a simulator here, so the behaviour is a simulated GPS read, so the results are slightly different between the two platforms. If you're on a physical device, it'd be wherever your phone is currently located. So, a quick recap on what we've done over the last 30 minutes. We have created a new app, run that app in developer mode, allowing us to rapidly iterate the development of the app's code. We've added some basic input widgets like buttons and text inputs. We've displayed the results in dialogues. We've added tab-based navigation between panels of content. We've displayed a matplotlib chart backed with a NumPy data series. We've added a map, integrated a phone's geolocation services to control the display of that map, including requesting the permissions required to use the geolocation services. And all of that has been done entirely in Python, using Python tooling and configuration files, producing an app that is completely native and entirely self-contained. Although I am a Python developer, the apps that I've generated could be uploaded to an app store or distributed on a website, and the only instructions the end users would need would be download the bundle and click run, double-click it to start. The resulting app would be indistinguishable from an app built with Swift on iOS, or with Kotlin on Android, or C# on Windows. And yes, there are BeeWare apps in both the iOS and Android app stores. All right, so that's what we've done, but how? What dark magic makes building a cross-platform app like this possible? Well, surprisingly, it's actually not that difficult. It is complex, but it's not complicated. Toga is based on a 3-layer architecture. The top layer, the interface, is the published API. That is what is documented as public API, what end users interact with. There is a single PyPI package for this, Toga Core. The interface then talks to a second standardized API, the implementation. There's an implementation for each individual platform. So Toga Cocoa for macOS, Toga iOS, Toga Android, and so on. And then there's the native layer, the actual native APIs. As an example of how this works, let's take a multi-line text input as an example. There is an interface layer, multi-line text input. That's the API that you as an end user interact with. It specifies that you can set a property named value of your multi-line text input. When you do that, the interface values setter calls the implementation over a setValue API. How is that implemented? Well, on iOS, there is a iOS multi-line text input widget that constructs a UI text view, the iOS representation of multi-line text, but iOS doesn't have a native concept of placeholder text, so it also creates a UI label. When you call setValue, it sets the text attribute of the UI text view and then hides the placeholder text widget because you've now got an actual value, you don't need placeholder text anymore. On macOS, NS text view, which is the macOS representation of a multi-line text view, does have a native concept of placeholders, but it doesn't scroll by default. So the Cocoa implementation of multi-line text input is constructed as an NS text view inside an NS scroll view. SetValue sets the value of the NS scroll view, and the placeholder takes care of itself. All right. But how does the implementation talk to the native APIs? Well, on each platform, Toga uses a language bridge to invoke native platform APIs. It's a different bridge on every platform, listed on the screen. Those APIs allow native Objective-C, C#, Java, or whatever language APIs that exist on a platform to be invoked as if they were native Python classes. What does that look like in practice? Well, let's say for some reason we needed to use the platform's native URL representation. You do a quick search on your search engine of choice, you find that the API on macOS and iOS is the same. It's called NSURL. Objective-C syntax is a little weird. It uses a plus annotation to describe class methods, so it appears to have a URL with string constructor. Once you've got an instance, the minus notation indicates that it's an instance method. So there's an instance method called URL by appending path component is directory. How do we use that information in Python? Well, we use Rubicon to import an Objective-C class, or the Objective-C class, and we declare that we'd like access to the NSURL class, giving us an object that appears to be a Python class. We can then call the class method of URL with string to instantiate a new instance. The argument to that class method is an NS string, which is the Objective-C native string class, but Rubicon will transparently convert any primitive types, including string, so we can just pass in a Python string and we'll get back an instance of an NSURL object that we can then manipulate. Now that we've got that instance, we can invoke an instance method, Objective-C. Calling syntax is a little bit weird, but the mapping to Python is very direct. The first argument to any method is just passed in as a positional. All subsequent arguments are keyword arguments. And so URL1.URL by appending path component, the value that we want as our path component, is directory equals true. All those values get passed through and transformed into their native Objective-C types. What about Java on Android? Well, again, a search will reveal that java.net has a class called URL with a public constructor that takes a Java string and an instance method, open connection, that takes a java.net.proxy object. Chakapy, which is the bridge layer we use on Android, lets you use Python import syntax to get at the class. So we can, from java.net, import URL, instantiate the instance using the constructor, passing in a Python string, again, transparently converting from a Python string to a Java string. And on the instance, we can then invoke open connection, providing a proxy object, wherever we've gotten that from. Windows and C# has a similar story with Python.net. On GTK, we're using the native PyG object APIs, which are mostly documented as Python anyway. Web and JavaScript has a similar story. Why tell you all of this? Well, first off, if a native API exists for something, you can almost certainly invoke that API from Python. There are a very small number of exceptions to this rule. C# methods on Windows that are declared async, subclassing abstract base classes on Android that don't have a default constructor, iOS and macOS C APIs that use SIMD vector types. These are fairly rare in the grand scheme of things. Most APIs you can get access to, and even the ones that are on that sort of exception list, there's often a workaround. You just got to close your eyes and hope in some cases, but you can usually make it work. Secondly, if an existing Toga widget is close to what you need, but not quite, and there's a native capability that will get you the rest of the way, you can invoke that code. There is a semi-official API standard in Toga that you can say on any widget, say widget._import.native, and you will get a direct handle to the to the native widget that Toga is using to implement that widget. So if you want your application to remain cross-platform, you may need to add if sys.platform equals iOS or whatever to guard around those native calls, but that's an if statement. It's not that hard to do. Third, this isn't Toga specific. All of the bridge libraries that Toga uses are available as their own packages, and you can use those packages in your own libraries, on your own projects. If you have got an existing tool, nothing to do with Toga, and you just need to call that one native API to do text-to-speech or call a machine learning API or whatever that your platform provides, you can do that. Going to extremes, you could, if you wanted to, write in Python a native iOS app directly using all iOS APIs. Same goes for any of the platforms that Toga supports. That is literally what Toga is doing, but with an extra abstraction layer on top. Apple, Google, Microsoft may not provide officially documented Python APIs, but you can still write native apps using their APIs from Python. And lastly, all of this means that contributing to Toga, or Briefcase for that matter, isn't as hard as you might think. You do need to get comfortable with reading API documentation and code samples in a new language, but that's not really even translation, it's transliteration. It's literally working out what the weird punctuation in an Objective-C call means in the context of a Python call. It's very much a learnable skill, and it doesn't take that much effort to learn the skill. I believe in you. You can do this. All right, so great, I've convinced you. You want to help. What does the future hold for BeeWare? A couple of the things I've already flagged. My co-worker Malcolm and I are currently actively working on iOS and Android packaging. Expect to see updates in the coming weeks and months. Once those tools are in place, the big task then becomes getting every package on PyBay to support iOS and Android. So how long could that take? We can't currently sign iOS, Android and Linux packages. If you know the metadata requirements and command line invocations, adding that capability to Briefcase shouldn't be that hard. We also want to add command line deployment to physical iOS devices. Again, that's mostly just working out the incantation to make it happen and then embedding that in Briefcase. I've flagged a few places where Briefcase will auto-detect that a command is required to invoke it for you, but there are some of those edge cases that we could probably improve the process and make it even better automation. Over the last couple of years, PEP 621 metadata has emerged as a standard for lots of the properties in Briefcase, but Briefcase predates PEP 621. We would like to be as standards compliant as possible, so there's kind of a compatibility process we need to go through. There are still a handful of widgets that are still needed in Toga. Mobile is missing a couple of key widgets. Web and textual need a lot more of those to get to parity with other platforms. Briefcase also stops currently with the process of packaging your app, but it might be possible to automate publication as well, like pushing the app to an app store. And lastly, there are platforms that BeeWare doesn't currently support. Apple Android watches, tvOS set-top boxes, VR headsets. I want to get Python everywhere. So that is cross-platform GUI development with BeeWare. If you do nothing else, I recommend going through the BeeWare tutorial, docs.beeware.org. That gives you a complete walkthrough, all the stuff I've spoken about today, plus more. Briefcase has plenty of configuration options and other details I haven't gone into, though. Briefcase's documentation is fairly thorough, so you can check out there. And I've also only really touched on the very surface of features of Toga. Toga's documentation has a whole lot more details, and the Toga GitHub repository has a whole lot of example code. If you like what you've seen here and you'd like to support the BeeWare project, you can join the project as a financial member. You can also back me on GitHub sponsors. The income we raise there is used to cover stickers and hosting and things like that. As I said earlier, I am paid by Anaconda to work on BeeWare, but the project itself is independently managed and funded, so that financial support is actually important. Or if work in kind is more your thing, we're always looking for new contributors. We have challenge coins for people who contribute. Come have a chat if you're interested. We've also got a Discord, plus discussion forums, ticket trackers for all the projects. Details on the website, beeware.org. Thank you all very much.
Thank you, Russell. That was amazing. We do have a few minutes for questions. The remainder will probably be outside. But yeah, 1 to 2 questions now, if you have any.
Thanks for your talk. This is extremely interesting and well thought out. I can imagine lots of use cases where you would reach for this, some hypothetical future version of this, instead of an older, heavier cross-platform. Instead of an older, heavier cross-platform library. But in terms of its scope, you know, what you'd like to turn this into, putting briefcase compatibility aside and putting licensing questions aside, are there cases where you would still imagine somebody reaching for PyQt or PySide instead of a more mature version of Toga?
In a future state, I'd certainly hope that we are at least as equal, at least as compatible, at least as widespread as PyQt is. Right now, if you need the full maturity of, battle tested for 20-something, whatever years that Qt's been around, by all means, go ahead. The one thing I will say is that briefcase apps are a lot smaller than PyQt ones are because PyQt's binaries are large and Togas are very, very small by default by comparison. But yeah, in terms of long game, I think it's in a similar sort of territory. Like the scope is about the same.
Yeah, I was just, I've only ever made one app in my life, and the problem I had was that the app wouldn't run in the background on my phone. How would you deal with that with BeeWare?
Okay, so apps running in the background on your phone are an issue with the operating system itself. Like as an issue of battery preservation, you essentially don't run apps in the background. The APIs for phone apps have very, very specifically carved out windows for the things you are allowed to do while the app is not in the foreground, usually along the lines of things like, I am asking for location updates, and so you will get an intermittent update to say, I have changed location, or I'm getting a notification that's being pushed to me, I need to respond to that notification and pop up a toast notification to the user. Essentially, you don't run background task apps by design of mobile apps. They are designed to run in the foreground or not be running at all so that they don't run your battery into the ground.
Okay, thanks. That makes sense. So if all I wanted to do was have it track my location, I could do that through BeeWare?
Yeah, absolutely. So when you set up your map, one of the things you can do is say start location tracking. There's an API to call start location tracking. You have a callback API that says, tell me when I've got a new location, and get a ping, depending on how it's been set up, like your location granularity and whatnot, a ping every couple of seconds to say, hey, yes, they've moved, yes, they've moved, yes, they've moved. If you look in the Toga repository, there is a hardware demo which goes through and gives you a running version of that. And you can take your phone for a walk and see it get a little ping every couple of seconds as it updates the location.
Wow, okay.